Hello and welcome to Bug Free Productions. In this video, we go from moving our paddle to fixing the collision problem we saw earlier, and also finishing some uh, finishing touches on the code part of it, and getting ready to move on to UI, being ready to move forward towards finishing UI and starting to add some of the art that I showed earlier, which is based off of a free asset, but is actually edited a little bit just to add some variety to the free asset pack. So with that, I'd like to welcome everyone and move on to the coding part. Let's go ahead and view what do we want to look at today. So I'm actually going to be looking at a couple different things. One is going to be fixing this paddle, so we might as well do that right away. Um, so this rigid body for some reason is causing there might not be problems with the two rigid bodies colliding on the ball and the cube, but something about it is affecting the bounce behavior. And I'm just, it's mostly a lack of interest that I don't want to spend more time focusing on how to fix that issue. So what we'll actually be doing is switching out the way the paddle works. We'll be switching out specifically that it uses physics to move and putting it in a translate system just to make things easier on me and you as well if you're following along and maybe don't have uh, a whole chunk of Unity experience to fall back on. So we're just going to remove this component, remove the paddle. We have to remove the panel in order to remove the rigid body because we required the component. So then we can remove this component. Um, actually, let's walk that back because you'll remember our events are set up for input. And so that I don't break this reference, maybe a smarter decision is to edit the script first, remove this require component line that we left in here, so that it no longer requires a rigid body on the object that it's a part of. We let it compile. Let it compile, and eventually it compiles. That's the wonderful thing, is eventually something happens. Come on. I don't know why this takes so long. We didn't change that much code. But, oh well, I guess. So, what can we look at here? There we go. Finally. Let's go ahead and remove our rigid body now. So I still want glidable. Now that there's no physics, it can't like bounce off and hit things, which is also fine. We don't really care about using gravity anymore. If I hit remove component. There we go. I hope I didn't remove anything important. Maybe just dropped a click. Um, but so now if we hit play, like we should notice that the box doesn't move and that falls. Trying to access it. That's just because we removed our rigid body. So let's continue to edit this. So open up the paddle script again. So we're going to go to editing. My mouth is kind of dry, but essentially what we're going to do in here is we're going to quit using rigid body. And everywhere we use rigid body, we're going to remove it. um, we'll just remove this. Body ref for panel or paddle we'll still need. So we'll still need that in there. Set up body. let's just grab our transform. So let's create a transform object here. Transform dot, it's not dot. So this is, I don't want to serialize it. I just want to get it. So I'm going to leave it as a private. Private transform body TF equal to, let's say equal to null by default. And then on enable, body TF equals get component of type transform. So just set the variable equal to the component transform on here. We'd actually, this is dumb. Kind of dumb though. Which even getting the transform seems kind of redundant here. It's good to know how to do this, but actually what I'm going to do is remove that as well. Because our paddle script is on the same level as our body, I'm actually just going to access the transform. So when we move paddle, we still have an acceleration. So still don't want a maximal, like a velocity too fast. We're actually going to want is probably a little different than when we used physics. And honestly, I just want to kind of delete this. Receive move direction. So this is still valid. Still want that. Move paddle. Still want that basic setup. So every fixed update. I might actually move this from fixed update to update because lightens up it lightens up the update or the fixed update method a little bit, which tends to do all of the physics transformations. So better to leave that with a little more accessibility for memory. And on enable. So we have on enable and we're going to set up a body. We don't really need to do that anymore. So maybe we could even remove that. If we delete that stuff, we're just left with our update, move paddle. I'd probably change these to be a move speed. So that my movement would be at a certain speed. And you could adjust this too to be like build up speed over time or lose speed over like when you release the keys. Work that way. I'm just going to do a really simple serialized field. Whoop. Serialized field, private, mob speed equal to 10 by default. It's a type, and the type should be float. Because while we're not doing physics, we are still using a bunch of vector threes, so we still want to use a float value. And inside the move direction, we're going to move in the direction move in input direction at designated speed. I'm not going to think about how to spell that other word right now. So we're just going to move on with this, des speed. Actually, I'll just use the variable name. So in move paddle, we're just going to do simple transform access. So transform dot position. And we can add vector threes together. So we're gonna do another transform dot position dot, not dot, plus a move direction. Um, and this is actually not quite right. Let's do transform position dot z equal to, or plus equal, can't assign vector threes, is that what it is? Cannot modify. All right. So let's, slight hiccup, no big deal. Let's do a new vector three. Vector three, n, and right. So n, let's just call it nv3 because I can't think very well right now. Doing a new vector three. That's going to be equal to, not equal to, it is equal to a new vector three with the parameters of transform, and this may look a little, you know, not the smartest idea, but dot y x. All right, and transform dot position dot z. Okay. And then we need to add the float value. This would be uh, move speed, correct. All right, we'll come back to this. So this line essentially is setting up our new vector three. Or it will be setting up our new position. Let's calculate how far we're going to move our transform object. Calculate the amount to move. This will be a float value. And the float will be, let's just do AMT move. And this will be equal to our a move direction, which I also want to rename. So if I click Control RR, I just want lowercase meter. NV3 is, okay, that's just an error from up here. So amount to move equals transform dot, we're gonna go right, because we want to move left and right. So transform will be on our x-axis by default, if we're still in world transform. So transform dot right, multiplied by our move speed, that is correct. And then multiplied by our tweening time. So we could manually set something up to do tweening, but since we're just doing something simple here, we can use time dot delta time. Transform move amount is equal to the transform dot right dot right. Okay. So transform dot right times move speed. Why is this not implicitly convert vector 3 dot float? Okay, because this is a vector 3. This is the problem with trying to do everything live. I don't really have time to prep anything. So I just kind of go live. So now transform dot right times move times speed. This is cool. This is an amount to move. Now all that typing that we just did here is kind of pointless, but let's calculate the amount we move. So we create a vector 3 amount to move, and the amount is transform dot right times move speed by delta time. So transform dot right would be normalized direction of right. So x1, y0, z0. And that multiplied by move speed is kind of like the magnitude of how far we'll move, and by delta time. So there's also the um, transform dot right kind of becomes pointless because what we would actually want to use is move direction. Okay, so vector 3 equals amount to move, which is equal to the move direction times the move speed by time dot delta time. And move direction is, as we did in here, did we normalize that? We did not normalize it, but since we're using deltas, it'll be okay. All right. So this should be fine. Vector 3, so what we'd actually want to do, we could either use the transform dot translate, or we could remove this. Transform dot position plus amount to move. And then assign change. Transform dot position is equal to the new vector 3. And if we were really good, we could probably do this all in one line. I like to break my calculations up a little bit because they make it more readable, and I'm not a math person. So we're gonna move on. So saving this up, we should be able to go back to Unity. Our things should all be like still connected. And when we hit play, so you notice it has a little bit different. It doesn't have the, kind of like the drag after physics ends, which at some point is both good and bad for the game. Depends what your feel is going for. Because I was trying to use it a little earlier. And I was having trouble actually getting it under the ball with the arrow keys, or W or A and D keys, rather. So that's a little helpful in that context. Let's also go ahead and think about, okay, so is everybody gonna want to play this with arrow keys? Probably not. So we can probably change our input system to reflect that. So kettle or pedal con, com. Can't really read that text. It's kind of small and a bit far away from me. But essentially, I'm gonna probably want to add another up, down, left, right composite. Um, and just add the path of, oh, and you can't really use listen. So for this one, I'm gonna add some mouse input, and I'm just gonna go delta up, and then this will be delta down. Delta left, and delta right. And again, you can get that just from, not listen, come on. From this by just going mouse and then selecting. So if we go ahead and run this, what do we look at? We have the ability to see bounce, and you see it links automatically, so I can move my mouse now for this, which is kind of cool. See if I can get it to corner bounce. Nice. Which might be a little bit difficult, so I might, you know, a way to fix that would either be through something like some more scripting, or we could change the shape of our paddle so that it bounced, had like flat sides so that it would bounce differently. But all the same, this should set up pretty nice for us. And we'll go ahead and continue on. So one of the things that we left off doing, that fixes our paddle and our bounce problem. So what can we do from there? We can probably go and check our scripts. So we did the brick, we did the ball, we did the game manager, and we were starting the level manager, I think, was where we left off. So let's look at our level manager. And we do level manager amount of behavior, bars, serialized field. So this is where we populated our bricks for the level. Um, we have the ability to remove a brick. We have the ability to add a brick. So give a brick, take a brick situation. So a couple things we'll still need for methods is gonna be end game. So this is probably gonna be like public, no, not public, private, void, end game. Our game is gonna kind of end here. So basically this should call with no parameters is what my thought process is, because everything that knows how the game should end, like the level. So actually maybe end level would be more appropriate. I don't want end level to necessarily do a whole lot. I kind of want it just to be here to, oh, tell the end of game canvas to turn on. Um, it'll probably turn off some references like the ball in the scene and whatnot. So do some simple things. Let's maybe list them out right now. So turn off ball, turn on canvas. So maybe do LVL canvas. And what else could we do here? Probably. That seems like a pretty good list for right now, actually. Let's think about how we do such things. So we could look for a canvas. We could look for a script we put on a canvas. Um, my preferred way, if we're sticking with simplicity, um, I've used other types of ways of doing it, but for simplicity of demonstration, we'll go ahead and just use a game object reference. So to show at ends of level. One thing I'm not going to use just yet, but I'm going to discuss, or not discuss, but I'm going to create the wireframe here, is a coroutine. Now, if you're interested, go ahead and look this up if you are interested and haven't quite really seen what it is. So basically, it's a yielding return statement that kind of runs and mimics multi-threading, but actually it runs on a single thread, which is a little confusing technically, but closer when I start beautifying things, we'll actually pay attention to starting to use coroutines because for execution, they're not always important for execution. And for this execution, they won't be, but they can be quite useful to make things look nicer and behave a little nicer. Private uh, game objects. This is going to be LVL and what happened? Nothing. LVL end canvas. Set equal to null. One thing that you can do here usually is that I'll show now is if you're using a bunch of serialized fields or just aren't always going to have a reference in that variable that might be null, or getting thing a method back that might return null, which Unity does sometimes. You might want to go if level canvas is not null. So if our variable is not null, LVL canvas dot set active, and I actually want that to be true. So there's this. We'll also want a reference for the ball. And we'll make this another serialized field, private. This will also be a game object. And this is just kind of getting used to using game object and seeing some of its properties. So we also want the same thing here. It won't be level end. This time it'll actually be ball. And again, we want to set it active to true. Oh, wait, nope, this is correct. My bad. We do want this false because we want to turn our ball off so that it quits falling, hitting, scoring, etc. Because eventually one of the things we want to do is put a field underneath the play area where if the ball drops below your paddle and hits that, it will be triggering a game over. So go ahead and save on that. Methods, region, coroutines. So we haven't really done anything in here yet. Actually, this should be in there. This was meant to be in there. Actually, do we just have an extra? That's why. We just have extra methods region for some reason. Okay. Yeah, it was just an extra region. I copy and pasted too many times probably. And so this is going to work as eventually game manager. So let's look at our level manager again. End level should be called every time we remove a brick, right? Um, so every time remove brick runs. And since I already defined it like with two if statements, maybe I want only one in here. So if, and this is not going to be anything to do with the ball, this is going to be with the list. So if bricks dot count is less than or equal to the number 0, then we're going to end level. And the reason I did it in here and not in here is just to avoid nested if statements, which can be confusing when you go back and troubleshoot your code if you have too many nested if statements. There's one horror story somebody told me about how somebody was trying to accomplish job security and just not made everything calculate with like 6 layers of if statements. And while it helped his job security, they couldn't really get rid of him. Once he did eventually leave the company, there you're left with um, essentially unusable, unupdatable code because if you don't mark everything clearly with a bunch of comments, especially, it's nearly impossible to go back and uh, figure out all of that, depending on how big your code is and how complicated it is. So we're going to go ahead and make bricks. So this is our remove a brick. Yeah, just making some comments so it's easier to find out here. So if the list is empty, empty. And the level. BEL. Okay. Um, we probably won't use this a whole lot, but I'm not going to delete it. I'm just going to leave it in there for possibility in case we add something that spawns bricks, which I think I mentioned previously. Gonna check the time. So this, we're not too far into it yet, or it's not too long of a section yet, so we're gonna continue. We're gonna do a game manager. So this, as we track the score, is very separate, you'll notice, from the level manager. So your level management, so basically scene management should be as independent as you can make it from your uh, overarching management. So measured in persistent levels, whether you do it by saving information or keeping a persistent object in memory, depends how you want to approach such a thing. But in this case, where you have a persistent game manager and then a level manager that split that kind of responsibility from overarching to um, the specific scene. Uh, and you can split this up even smaller so that eventually when you make more complicated games, you'll have overarching, then you'll have scene, and then inside the scene will have its own little subsystems. But for this example, we're keeping it very simple. And we're moving into the, let's go see a playable version of what our thing looks like so far. Um, it might not exactly, yeah, it becomes pretty hard to actually get a different angle on it. So maybe I'll even, let's go ahead and delete these. That way when we play, probably still doesn't do anything. Let's make a canvas so we can do some testing on our code. Did I create a canvas yet? Does not look like it. So if I right click, create empty, would be bad idea actually. I'll do right click, create UI, canvas. What do I want to focus on a canvas? Well, immediately this is by default set up honestly pretty poorly for most projects. Um, Not that it's wrong for all projects, but for most projects, you're going to look at, you probably do want a screen space overlay. Target display, that's not bad. Shaders, fine. Canvas scaler, definitely not set up for most projects. Scale factors, fine. Pixel reference, 100 pixels per unit, fine. But I like to scale with screen size. Constant pixel size gives you more control over the pixels, but can be kind of irritating if you want to scale graphics over like multiple different screen sizes. So I do this, and I always go with a reference of 1920 by 1080. Um, there's a couple reasons for that. One, it has the 16 by 9 aspect ratio, and so that's your normal rectangle screen. And secondly, this is not a high, like ultra high resolution, like a 4K display. This is just simple high def display, which looks nice, um, and doesn't require me to have like really high rendering. So I usually stick around 1920 by 1080. Sometimes I've dipped over into 4K, but I mean not 4K. Sometimes I dip over into 2K, but honestly, just hardware cost wise, I usually develop for stuff. Keeping in mind this level of quality being my minimum quality. So that's what I like to use as my reference when I'm first start building things. So canvas scaler is really the only thing I have to adjust immediately out of box, usually. Um, Now if we look at our canvas, uh, we're gonna need to just kinda, there we go. Okay, so let's go ahead and add something to our canvas. Let's create a button. So UI button. Um, Button using Text Mesh Pro. I didn't import Text Mesh Pro, so we'll just grab the essentials, which doesn't take very long. Um, Being now that regular text is deprecated, I find it really dumb that you still have to import this package. Um, but maybe we'll give them the benefit of the doubt and like give them the benefit of a doubt and think they have something going on. So you'll notice that this is flipped. Um, is kind of a problem. Oh, that's right. Can't do that. I do kind of wish they'd switch the WSAD keys to be the move controls because then I wouldn't have to constantly switch between my arrow key shift and mouse and WSAD when I'm programming games. Um, it's just very funny that that consideration wasn't made and it was opted to go for shortcuts instead of match that. But any rate, we'll continue. So now our button's here. Now we're facing our canvas the way it was meant to be faced. Um, so let's put it down here and let's actually make our button pretty big. Uh, where is button? And you'll notice we have some rect stuff. So this is a rect transform. Transform on UI works a little bit different than transform for world. Um, let's just go ahead and bump up this to like what is it, 500 by 200 is usually what I run for. Um, yeah. Also want to bump up my text size a little bit. If my speech is bad, it's probably because I'm trying to mask my, what is it, remove my fan noise. And to keep concentrating, I have my headphones on. So, um, quick recording trick for those that are interested in recording uh, music or whatever, or sound effects. Keep one ear of your headphones off if you can, because it'll give you, then you'll be able to hear back normally what your volume level is, your tone, and also like your um, just speech in general will be easier if you can hear yourself. So what can we do here? Looking for it's actually under the other object. Yep. So button is usually a button object with an image and then a text. So my text size is going to be something like 50. Yeah. And you'll just get a feel for it as you keep using different things. Libertarian sans serif is good for like mockups and everything. I usually find that I end up pulling Arial Black or some type of more well-used type of font, but this is certainly workable. It might even fit with your game at some point. But this is going to be our next button. And after I switch this out, so on the text object, just switching that stuff out, switch out our text, change our size. I'm going to go ahead and jump up to the button again. A couple things I want to look at the button. So I adjusted the size 500, 1200, or 500, 200. But what do I want to do now? I want to kind of go back and change some of my, need to check this real quick. Yep, looks good. Check my normal color. So normal color, white, fine. We're just gonna highlighted color. Maybe we'll change it to yellow. Press color, change that to green. Selected color, maybe change that to purple. And disabled color, I don't really want one. So essentially play. So you'll notice I can highlight the color. Then I click it. I want selected, it's green. I release, it's purple. So that's kind of nice for that. Just gives us kind of some feedback on our states, on our button states. So essentially what you might want to do is either use these colors or alternatively um, change your image colors, create like a script to change image colors based on that, or change the images of the buttons altogether. Um, we'll probably look at that when we go to make things pretty, but for right now, we'll leave it here. We're going to go, you'll notice an event system got added as soon as we got the canvas. That just allows us to like click on the button, stuff like that. Makes our lives a lot easier. And if we control save, so anytime you make a prefab with an event, with a canvas, I recommend putting the event system in with it, just because then you're certain that an event system will exist with your canvas, instead of trying to spawn it in after the fact, which can be a real pain. So that's our broken brick, our player, our score. We're setting up our button. And then we kind of need a level manager. So we created the level manager and added this level manager script to it. You'll notice we have elements now and no objects. So let's go ahead and turn that off a little bit. We have a level end canvas, and I kind of want canvas to be that, right? So there's our canvas, and our ball is ball. So now if we have these all set correctly, and we run and we hit, we notice the ball did get hidden, right? So let's do that again and keep an eye on the ball. Yep, got hidden right away when it hit that brick. Ran script, did the brick. So that's kind of cool, right? Canvas, ball. So that's working correctly. The only reason this didn't become visible is because it wasn't invisible by default. So canvas, usually I do this through code. And when we prettify it, I might, but for right now, I'm just going to hide it, which essentially makes it inactive. So then if we do the same thing, hold on. Okay, hide. Okay, it's just, we have to do this one. Hiding only actually hides it in the inspector. Uh, or hides it from the scene view to actually canvas. That's what I wanted. To actually turn the component off, set it inactive, we actually have to hit this check mark. So a little bit of a miscommunication there. We can hide it from our view, but we don't actually hide it from our game or turn it off in our game unless we uncheck this box next to the object. So canvas uncheck. And then if we hit play, we should see everything turn on and off correctly. Then we could go next. So this is all set. What's the next thing? So a couple things we could do is to create more variants of brick. We could create a different paddle. We could, but I think the thing that jumps out to me most is to actually set up our game boundary. So let's go ahead and create a new object, create empty. I'm gonna call this, ooh, what should I call this? Maybe I don't want an empty one actually. And it'll become obvious why in a moment. We actually want a 3D object because I want a cube. I want a visible cube. Is visible in the scene? It's not visible in the scene. Why not? Transform, right click, reset. Cube. Okay. So if this guy's here, that's not really going to help us in any way. So what I like to do when I'm creating boundaries for a lot of games is I'll actually want to go ahead and edit this a little bit. So I'll just take like the rect tool and kind of box in my area. And sometimes the easier way to do it rather than using a tool is just to use the scale. If I use scale, I only want to scale along X because that's my X. So my left and right in this case. So let's say something like 10. I'll say something like 20, 5. Better. What is this, by the way? Game manager. Let's name it. Oh, right. One of them destroys the other if it's that was demonstration cubes. Got it. Sometimes I forget what I did for demonstration and what's actually important. That's dangerous. So always keep a list of your essentials, guys. Um, so game manager's good. Cube. This is our game over manager. Game over manager. So how do we handle a game over manager? Well, this could also be part of our, yeah, what would we do? Maybe this is more of a, so the game of Brick Breaker, the idea is it hits this field, right? And that's a life. So we remove the ball. So maybe we want um lost fields. Let's call it out of bounds. Um, just kind of difficult to think of naming sometimes. So let's do out of bounds. And what do we do for out of bounds? We probably want a new script, right? So probably an assets scripts. we could create a new C# script that is for out of bounds. Out of bounds. And then we have out of bounds. So this object would just go on out of bounds once it finishes generating. And then go over to out of bounds. I just drag it on there, but you can also add component. Just, so this is all fine. Out of bounds is now on the out of bounds object. This is it. This big white bar at the bottom. And in the interest of keeping the video short, I'll stop this video here. So to everyone watching either on the video or on the Twitch channel, uh, remember to like, subscribe, and follow at what should be on screen right about now. So you can follow along at twitch.tv, or you can visit the YouTube channel where these recordings will uh, be posted, not quite regularly, but there's also a playlist that you can watch to help catch up. If you haven't watched some of the other ones, uh, as Twitch tends to disappear probably about 5 days or something, 5 to 7 days. So thank you for watching, and we'll see you in the next video.